Hello. So sorry I can't be with you again today. I'm currently isolating at home while waiting for test results. Hopefully everything will be fine. So today's lesson, you're going to be looking at the eye. Now I'm going to try and doing a video for you to help you with the lesson. You still have got your booklets and the questions to complete in them as well. But we'll look at the eye. Now, our eyes are what we use to detect light. They have receptors in them that respond to light stimulus, and they take that message to the brain. And obviously that's all we need to know in terms of combined science. However, for triple science, we need to know a little bit more. So we need to look at the structure of the eye, how it works, and any common problems with the eye, which we'll look at in the next lesson. So here we have a very badly drawn diagram of the eye. It is very similar to the one you've got in your booklets, but we'll have a look through everything that is in there. Now the first part we've got is the cornea. The cornea is there. It's there to help protect the eye, and it will help refract some of the light. Then inside of the eye, as we look in there, if you look at each other's eyes, you'll notice you've got the black circles in the middle. That is a pupil. Now your pupils are just a hole. It's what allows light through, and they can get larger or smaller. The reason they get larger or smaller is because we have something around the outside of it called the iris. The iris can contract and relax depending on how much light needs to go through. So if we need a lot of light to go through, for example, if it's very, very dark and we want more light in, the iris will contract. The gap will get bigger, the pupil will be larger, and it will allow more light to go in. If it is very, very bright and we're getting too much light in, we don't want to damage the cells at the back of our eyes, the iris will relax. It will get small, the pupil will get smaller and will allow less light to go in. If we have too much light going in, we can damage the cells at the back of our eyes. So the next up, we've got this bit here. This bit is our lens. Now the lens is the part that refracts the light the most, so it will decide how much the light is going to bend. And that is controlled by two things. We've got the ciliary muscles and the suspensory ligaments. So we've got the ciliary muscles, which are here, and we've got the suspensory, top and bottom. We've got the sensory ligaments as well. Now these work in conjunction to change the shape of the lens. As the light goes through, it will then hit the back of the eye, and we have this bit here, which is called the retina. Now the retina has rod and cone cells on it. The rod and cone cells are our nerve cells that detect light. They're called rod and cone cells because they are shaped like rods and like cones. They detect different amounts of light. We get colour and black and white. We can then get an image. So these will detect the light. They are our receptor cells. They will then send the message down what is called the optic nerve. Optic referring to light, and nerve, it is part of our nervous system. It is a sensory nerve, and it will send it down towards the brain where it can be processed. Now we've also got around the eye, we have something called the sclera. The sclera is the protective part around the eye. It's very, very tough. It's what gives our eyes the white colours when we look at them. Now we've also got something down here. This part here is called a blind spot. We've got no detectors here, so no receptor cells. If I can spell, R-E-C. Okay, there's a C in there as well. No receptor cells. There. We can't actually see anything if light hits this part. Now we're not aware we've got one because our brain is very, very good at working out what image needs to go there, so fills it in for us. So this is the structure of the eye. You do need to know the structure of the eye and what part is where. So we're now going to look at how our eye can focus on things if they are close to us or if they're far away from us. And it all depends on how the light is coming to us. Now, if something's very, very close to us, the light is coming at quite an angle. It's not parallel, so the light will come like that. It's not parallel, and our eyes need to refract the light so that it ends up at one point at the end. Now this is where we're getting into a bit of physics. So as light enters the lens is of a different medium to the rest of the eye and the air outside. It's more optically dense. By changing the thickness of the lens, we can change how much the light refracts. Now, obviously, you can sit down and work out how much it's going to refract and whether we need a thicker lens or a thinner lens to make it refract more or less. But to get something that is close to us, focused, we need to get this light focusing back to a single point here. So the light will bend towards the normal as it comes in, and it will then go away from the normal on the way out as it speeds up. And we get to a point here where we have it all focused onto one individual point. If it's not focused on different points and we couldn't bend the light enough, images start to look a little blurry. So if something is near to us, there are a variety of things that can change. We've got the ciliary muscles. We've got the suspensory ligaments. Now these both affect the size of the lens, or rather the thickness of the lens. And they can contract, or they can relax for the muscles, and they can slacken, or they can stretch for the ligaments. Now when something is near to us, the ciliary muscles will contract. The sensory ligaments will slacken, they'll get looser. There's very, very low muscle tension. Our lens is now getting a bit more relaxed. The lens itself gets fatter or thicker, we can call it as well. And that allows the light to refract strongly. I think if we have a very, very thick lens, we can refract the light a lot more. Now, if something is far away from us, the light itself is coming in pretty much parallel. Not quite parallel, but pretty much parallel. So as it then goes through the lens, we don't need to refract it as much. We're not going up and down again. So we're going to go through pretty much straight. We're already parallel or parallel to the normal. We're not going to get any refraction as we're going into the lens, but then coming out, we do want to get a bit of refraction as well. If we want, we can draw the normal on there as well. And we'll just see that imaginary line that is perpendicular to the surface, so where the light is coming out or entering the medium. So when things are far away, our ciliary muscles, they will relax. Our suspensory ligaments are going to tighten. Our lens is going to be thinner. And our light is only going to be refracted slightly. Now there are two ways you can try and remember all of this. You can either just remember it, try and learn it as best you can, going over it and over it again. Alternatively, you can think about what is happening with the lenses, what's happening with the light, what angle is it coming in at, so what's that angle of incidence, and how much does it need to be refracted by for it to end up in one point. And a thicker lens will give us a greater refraction, meaning we can get 1 point. When the light's going from far away, it's already parallel, doesn't need to refract as much, we only need a thinner lens. Now you have got some questions in your booklet to go through, all the information is in the booklet at the start on the new information part. Please go through that, try and match up, try and name the components of the eye, matching up the eye twix function, labelling the parts of the eye, talking about how the light is refracted and focused, talking about why the pupil will change size depending on how much light we need to get going in, various extended answer questions that are going to be linking in information you have looked at lessons before. We will go through these the next time I am back in with you, and we'll go through the brain as well. Again, sorry I can't be there with you. I know it is frustrating. Unfortunately, I'm having to isolate at home while we're waiting for some test results. Hopefully I'll be back in a few days. Have a good day and take care.